So we can use the Pythagorean theorem to find the length of missing legs on a right triangle. So we always have to make sure that we have a right triangle here. Okay, so I'll mark in my 90-degree angle. So for our Pythagorean theorem, again, it's leg squared plus leg squared equals the hypotenuse squared. So when I write this as a squared plus b squared equals c squared, a and b are the legs and c is the hypotenuse. So the first thing that you really need to make sure you do is have a look at your triangle and identify which sides are your legs and which side is the hypotenuse. So probably best to start with the hypotenuse here, okay? So this is the longest side and it's directly across from my 90-degree angle. So this side here is c, okay? Making the area of this square c squared. And it doesn't really matter which side I say is A or B, okay? For the sake of argument, I'll just say that's A and that's B. If I had labeled those the other way, that would be fine. So sometimes you're just asked to find the area of one of these missing squares, okay? So if that was the case, say this one here I was given as 25 centimeters squared, and I was given this one down here as 16 centimeters squared. So if I was asked to find the area of the green square, all I would need to do there is subtract these two areas. Okay, so the area here would just be 25 minus 16, or 9 centimeters squared. Okay. Now, if I wanted to find missing sides, again, I would take the square root of those numbers. A here would be 3, B would be 4, and C would be 5. Okay, so that's all you really need to do if you're finding areas. Most times when you're using the Pythagorean theorem, you're asked to find side lengths. So let's set one up like that. Here again, I have a right triangle. Okay, this is a 90-degree angle. So let's use some sample lengths here. So I'll say that is 8, and I'll say that is 5. And I'm going to look for this length here, okay? And I'll label it L because I know I'm looking for a missing leg. So here I'm going to find L using the Pythagorean theorem, of course. So I would say 5 squared plus L squared equals 8 squared. Okay, so, or you could say L squared plus 5 squared. It doesn't really matter the order that you add those in, of course. So my first step here would be probably to subtract 5 squared from both sides. So if I subtract it from the left-hand side, it's gone. I'm only left with L squared there. And I'll subtract it over on this side. Okay. Now, if you're used to balancing those equations, 5 squared minus 5 squared there, and they would cancel out, right? Okay. So I got L squared equals 8 squared minus 5 squared. So L squared, 8 squared is 8 times 8, or 64. And 5 squared is 25. So, subtracting those, 64 minus 25 is 39. So, I have L squared equals 39. So what I have found here is the area here, okay? I know that this is 39 units squared, okay? So I'll just say unit squared because I never really assigned a unit to this one. So if I want to find a side length, knowing that the area is 39, I'm going to have to take the square root. So square root 39 will give me my missing side length. So 39 is between 36 and 49, much closer to 36. So a good estimate would be 6.2 or 6.3. I'll say it's approximately 6.2 units. So that is how you can use the Pythagorean theorem to find a missing leg in a right triangle. Hope that helps, and we'll tackle more Pythagorean theorem problems in the upcoming video.